All right, today we're going to try and get inside the head of one of AI's most influential figures, Ilya Sutskever. We're going to unpack a really fundamental and, frankly, kind of paradoxical shift that's happening in the field right now.
Sutskever kicks things off with this quote, and it really hits home, doesn't it? The whole world of AI used to feel like pure science fiction, and now, well, it's just normal. But underneath this new normal, there's a fascinating and strange paradox that's forcing everyone to completely rethink how we build artificial intelligence. So let's dive right into it. Section 1, the AI paradox. Okay, so here is the heart of the problem. On the one hand, you've got these AI models that are just crushing it on paper. They're getting superhuman scores on these incredibly difficult benchmark tests, the so-called evals. But then when you actually try to use them in the real world, these same models can be fragile, totally nonsensical, and just, well, weird. This is the big question Sutskever is wrestling with. How do you square that? How can something be a genius that aces a graduate-level exam, but then turn around and get trapped in a ridiculously simple, buggy loop? He gives this perfect, almost comical example. Say you ask an AI to write some code. It has a bug. You point it out. The AI is super apologetic. Oh my gosh, you're so right, and it fixes it. But in the process, it creates a brand new bug. So you point that one out, and it apologizes again, while reintroducing the original bug. You can literally get stuck alternating between these two bugs forever. So what on earth is going on here? Well, to explain this bizarre behavior, Sutskever uses a fantastic analogy which brings us to our second section, the overtrained student. Imagine two students getting ready for a huge programming competition. Student number 1 is a grinder. We're talking 10,000 hours of practice. They've memorized every single problem type, every solution, and they absolutely ace the test. Then you have student number 2, the natural. They only practice for about 100 hours, but they just get it. They have an intuition for it. They also do well in the test. So Sutskever asks who's going to have the better career in the long run. It's the natural, of course, because they have true understanding, not just rote memorization. And here is the crucial connection. Today's AI models are the ultimate grinders. They've essentially been trained on every test question on the entire internet. So yeah, they can ace the exam, but they're missing that deeper, more flexible understanding that would let them handle new situations gracefully. But that begs the question, right? Why are our AIs such amazing grinders and not intuitive thinkers? To understand that, we kind of need to look at how we got here. And that brings us to Section 3, from scaling to research. Sutskever breaks down AI development into 3 distinct eras. From about 2012 to 2020, we were in the age of research. This was all about tinkering, experimenting, and discovering foundational ideas like the transformer. Then, from 2020 until basically now, we entered the age of scaling. A simple, really powerful recipe took over. Just throw more data and more compute at the problem, and you get a better model. Companies loved this because it was a pretty low-risk, predictable investment. But now that scaling recipe is hitting a wall. The data on the internet that we use for pre-training, well, it's not infinite. And as we've already seen, just making the grinder student study 100 times harder isn't going to magically give it true understanding. So we're swinging back into an age of fundamental research. The big difference this time? We have these absolutely massive computers to play with. This leads us straight to the new frontier, which is Section 4, the quest for generalization. This is the core problem that we really need to solve now. So, to get to true generalization, Sutskever argues that AI needs a critical component that we humans have built in, a value function. You can think of it like an internal gut feeling. His analogy is chess. You don't need to wait until you're checkmated to know that losing your queen was a terrible, terrible move. That immediate sense of, oh, I've messed up, that's a value function. It's a guidance signal that kicks in long before you get the final score. And what's the human equivalent of this? Our emotions. Our feelings act as this incredibly powerful, built-in value function. Sutskever brings up this amazing real-life case of a man who had brain damage that wiped out his ability to feel emotion. He could still solve puzzles and think logically, but he became totally incapable of making even the simplest decisions, like which pair of socks to wear. He had lost his internal compass. So the new goal for AI is to try and replicate what makes human learning so powerful. Our robustness is just staggering. We handle unexpected curveballs with ease. Our sample efficiency is off the charts. I mean, a teenager learns to drive in maybe 10 or 20 hours, not millions of simulated lifetimes. And so much of our learning is unsupervised. We just figure things out by living in the world, not by getting a constant reward signal for everything we do. This all points to a totally revised vision for the future of AI. And that's our final section, continual learning. The old vision of artificial general intelligence, AGI, was basically to build an oracle, a static, pre-trained system that already knew how to do everything from day one. But Sutskever's point is that this just isn't how humans work. The new vision is the continual learner, an AI that's more like a brilliant, eager student that can learn to do any job, not one that already has all the answers. And that right there is the profound shift. The real goal, the ultimate product of AI research, isn't a finished, all-knowing mind. It's to build the ultimate learning algorithm, the process of learning itself perfected. This reframes the whole conversation, doesn't it? It stops being about just what AI can do for us, and it becomes about what it can learn from us, which leaves us all with a pretty critical question to chew on. If we are building the ultimate student, what are the most important lessons that we, as its teachers, need to show it?